Hello, everyone. Thank you for joining the Prihoda webinar. We're just going to give everybody about 2 to 3 minutes here to get joined up, and then we'll be right back, get started just in about 2 minutes. Okay, thank you everybody for joining. This is Nathan Martin from Odell, and I appreciate you guys taking the time out of your day to sign up for our webinar on Prihoda Textile Air Dispersion. Today we have Anissa with us, and she's going to be doing the presentation. And before she gets started, just a little bit of housekeeping. You'll see that on the right-hand side of your screen, there is a question mark bubble. If you have any questions or answers throughout the presentation, feel free to type those out within the chat bubble there. I will answer those near the end of the presentation. If you have something that needs to be addressed immediately, if you'd also put up your hand, I can interrupt Anissa and get that question answered right away. But would like to try to keep most of the questions till the end just to keep it flowing. But that's about it. If without further ado, I'll leave this to Anissa to take it away and present. So thanks, Anissa.
Thank you, Nathan. Hi, everyone. Thank you for joining us on this afternoon. My name is Anissa Reed. I'm with Prihoda North America. And we are a company founded out of the Czech Republic. However, Prihoda North America is based in Mobile, Alabama, inside of the United States. I work remotely from Georgia. So again, I just want to thank you all for joining us, and just a little empathy here for anyone that is personally going through this virus thing to where it's touched you beyond the quarantine. My heart goes out to you. If it's touched you in any way to someone sick or passed away, my condolences to you. I'm going to go ahead and move forward with this presentation. Okay. Okay, so this is an AIA accredited course, and for anyone who needs credits, just let Nathan know, reach out to him. It is accredited here in the United States with AIA. So if it applies to you, just reach out to Nathan and I can make sure to get over your certificate of completion and also log you into AIA with this credit. It does give you a 1 hour LSU, which has a health, safety, wellness designation. So the course overview, textile air dispersion systems, they've come a really long way from when they first started to be used for HVAC systems about 35 to 40 years ago. Fabric ducts is really like a misnomer because fabrics are more so a diffuser than it is a duct, but it kind of sort of operates like a duct and a diffuser at the same time. So this course will examine the similarities and the differences between fabric ducts and metals, where to use them, how to use them, where you can get creative, and how it can provide the comfort that you need in the space compared to metal ducts. The learning objectives, this is the only slide that I'm actually going to read from for you guys. So upon completion of this course, you will understand the similarities and differences of textile air dispersion systems compared to traditional metal. You'll be able to discuss the components and the construction methods of textile air dispersion systems. You'll be able to understand the basic design, installation, and maintenance considerations for textile air dispersion systems. You'll also be able to gain insight into the wide application possibilities and benefits of textile air dispersion systems across different applications. So what are textile air dispersion systems? They are systems that are ideal for virtually any open ceiling application that has exposed ductwork. They are custom engineered for optimum distribution in any space. They can be dyed or printed to match or complement any interior design. So if you want the fabric ducts to match what's going on in the ceiling, like you see here in this picture, you can do that. Or if you want the ducts to kind of give like a visual pop, they can be made in vibrant colors or with prints or with lettering or logos on it. They are more cost effective than traditional metal systems simply because you don't have to paint them, you don't have to insulate them, and you don't have to seal them. They can also cut down any transportation and labor costs because unlike metal, which are, metal is very heavy and bulky, but with fabric ducts, they can just fold up into boxes and they can be easily air freighted. So some basic characteristics. So again, like 35 to 40 years ago is when fabrics began to use for HVAC systems, and it was started in Europe for slaughterhouses. At the time, they used these cotton or burlap material that was made from the sags that product came in, and that posed a couple of problems, of course. With cotton or burlap, it can cause for mold and mildew issues, and then also it can become a fire hazard. So fast forward to today, all of our modern fabric systems are technically developed and they're made with a fabric is a highly engineered polyester fabric. And we use this material because it doesn't sweat, it does not rust, and it does not corrode. And as I mentioned before, it does not require any type of painting, sealing, or insulation, or any other finishing that metal ducts would require. It can be designed for precise air distribution and designed to fit in any type of structure. It can follow the slope of a roof or even go around the curve of a pool. They can also come in two different ways. Fabrics can be made permeable, which is like a breathable fabric, which creates an air barrier that prevents any condensation from forming, or they can be made in non-permeable. Now with non-permeable, you would use that to transition air from one space to another. Like if you have, let's just say you have a gymnasium to where you want to connect off a main trunk line of fabric duct and run it over into a room, maybe into a storage closet, you would do that more so in a non-permeable fabric. So in terms of fire resistance, most people, when they think fabric, they think it's a fire hazard, right? Well, fire resistance is a concern for safety as well as code compliance. So there is a misconception there. All modern manufacturers, all of their materials are tested to UL 723 as well as UL 2518, which combined ensures minimal flame and smoke spread. And this is based on the NFPA 98 standards as well as it keeps its durability over time. So with these standards, it ensures that you're not going to have any type of fire hazard with the fabric by using fabric ducts. And back in 2012, the International Mechanical Code began requiring compliance with UL 2518. So we are approved in building codes all across North America. So in terms of the mold and mildew resistance, again, because our fabrics is a highly engineered polyester, it does not rust, it doesn't sweat, and it doesn't corrode, and it's a non-organic material, so it does not provide a food source for microbes to feed on and grow. So you don't have to worry about like the old ducts when they were using that cotton and burlap. Nowadays, we don't have that issue. We also, most manufacturers do have a option for your sensitive projects, like your critical applications, let's say food processing or your health facilities. It's really not necessary, but most of them do require an extra protective coating. So most manufacturers do have an extra protective antimicrobial coating fabric as an option that can be chosen for these type of applications. When it comes to condensation, the permeability of the fabric, going back to that, because of the permeability of the fabric, it creates an air barrier. It's sort of like a thermal air barrier around the diffuser surface, and that prevents the warm, moist air from the space from making contact with the duct. So when the duct is cooling below dew point, you don't have to worry about condensation. It effectively prevents condensation. So this can also be accomplished with double wall metal. But there still can be an issue to where even if you do use double wall, there still can sometimes be an issue around the grill, the diffuser grills. If an owner decides that they want to use a single wall metal duct instead in an area of high humidity, we know that that single wall metal duct will sweat profusely and the maintenance people are going to actually spend a lot of time cleaning that stuff up. So you can actually compare fabric ducts to single wall metal ducts, with the exception that you don't have the issue of condensation in areas of high humidity. They're also easily maintained. So for simple maintenance, fabric systems are made in zipper sections that can be easily unzipped to be laundered in commercial washing machines. The dyed fabrics, they remain color fast. You don't have to worry about them fading over time, even with several times washing. Now, washing is at the discretion of the owner. They do, all fabric systems do come with maintenance instructions, but the frequency depends on the application. So typically applications that are like gyms or pools, they rarely take their fabric ducts down to wash them. But food service systems, like for your food processing, let's just say like an ice cream facility, they're making ice cream, or they're processing meat, or even your health facilities, they will order an extra set of ducts so that there's no downtime when they take one set down to wash them. And then especially for times like this where people are concerned about disinfecting their fabric ducts, this is possible. All you have to do is just take your standard detergent and add a sodium percarbonate additive to it. This will clean and disinfect the diffuser without damaging the fabric or the color. So if you think industrial strength OxyClean, that's what you would use in order to disinfect the duct. And yes, it does kill viruses like the coronavirus. So lightweight, fabric systems are exceptionally lightweight. It averages approximately 1 pound per linear foot, making them ideal for retrofit projects and even renovation projects because they add virtually no load to the roof structure. So, and as I mentioned before, because they are so lightweight, it greatly reduces shipping and handling costs compared to metal systems of the same design. So if you can just imagine with the heavy bulky metal that has to ship by truck, by freight, ground transportation, and you can't fold metal up and put it in a box. But with fabric duct, you can just fold it up in a box. It can be easily air freighted, FedEx, UPS, or whatever method the manufacturer uses. And that leads to the next point of cost effectiveness. One of the most important differences between metal and fabric systems is the cost. It is fast and simple as far as installation goes, so that dramatically reduces the labor cost. Of course, contractors really like that. But if you combine that with the additional savings in the materials, it can result up to about a 70% savings compared to metal. So anywhere between 30 to 70% you can save using fabric over metal. So additional characteristics, fabric systems are also, they offer sustainability benefits compared to metal. The sustainability of any fabric is manufacturer specific, because some fabrics are available ranging from 35% post-industrial recycled content to 100% post-consumer recycled content. And with those fabrics, they can save up to 11 water bottles per square yard. There is a fabric out there on the market that is made from 100% post-consumer recycled water bottles. That is the one that can save you 11 water bottles per square yard by using that. And it can also contribute to materials and resources credits for LEED. I'm not sure how applicable LEED is to Canada, but if you don't, I'm not sure if you guys have LEED there, if you have a similar organization like LEED, this fabric can contribute to those materials and resources credits. So in terms of sound, textile systems do not resonate and transmit sound the way that metal systems do. So, you know, if there's no sound attenuation in the fabrics, in the metal system, it will travel throughout the metal. You would hear it in the room. Well, with fabric systems, if there is no sound attenuation, the sound will just break out right at the wall, right where the fabric connects to the unit. It will not travel and resonate throughout the fabric system. But they also have fewer hard angles and edges. So as the air is traveling through the fabric system, because it doesn't have hard angles and edges, it does not resonate sound. And so it's inherently quieter than using metal. They can also be sized and configured to meet extremely low NC levels and spaces, making them very well suited to sound sensitive applications like your recording studios. That's what's shown in this picture here. This picture is actually of a sound recording studio in Montreal. They recorded the Netflix series House of Cards. There's also sound attenuators, fabric sound attenuators on the market, and this significantly knocks down any type of sound reverberation in a system, especially if you do not have any sound attenuation on a system for whatever reason. So this particular system is made with rock wool, and it has some other different components, the way that they construct it, but it, like I said, it's like a, it kind of looks bulky here in this picture, but you can see how that opening right there is a little bit smaller than the actual attenuator. So even though I don't have a real picture right here showing that, but if you can picture the fabric duct connecting right there at that outlet where you see it kind of like that X in the middle. So your diffuser will be a little bit smaller than the actual attenuator itself. It's not the most beautiful looking thing, but it does serve its purpose to where you do need to knock down sound if you're like in a recording studio or even a library. So custom aesthetics. Okay, so with round is the most common shape. That's what most people think, that round is all that fabric ducts can do. Sometimes they think that it's the only shape that metal can do, because round is even the most common shape with metal. But with fabric duct, it can also be made in half round. That's the top right-hand corner picture. Half round can be suspended just below the ceiling with threaded rod or with cable drops, or they can be surface mounted to any finished ceiling. They can also be vertically suspended on columns or walls to act as displacement ventilation. This can also be done with the ellipse shape. The ellipse shape is available for draft-free air distribution and lower ceiling applications like classrooms and offices. And that's what's going on in this picture, bottom right-hand corner. They've replaced the metal diffusers that they had in there with these fabric diffusers for more comfort in that space. Quarter round can also be made, and these just tuck up between the ceiling and the wall. That top left-hand picture is of a movie theater to where they wanted the fabric duct to blend in with their black ceiling panels. So as you can see, they have quarter round on the sides, they have a half round running down the middle. Now tucking fabric up in between the wall and ceiling like that is kind of like hanging heavy drapes. So where you would normally have a lot of your sound reverberation happen up there in the corners, that significantly knocked down any type of sound reverberation. On the right-hand side, you see fabric can also be made in rectangular shape. Now, the rectangular shape can be made for either positive or negative pressure. So for applications to where you need to pull a return, maybe in a pool room or even in a data center to where you want to remove hot air from hot aisles, that can be done with rectangular fabric duct. Custom finishes, so most manufacturers do offer a stock of several standard colors, but the custom color is also an option. This could be done in either two ways. It can either be vat dyed to where a manufacturer can send it off to a third party to have it vat dyed, or it can be done with a process called dye sublimation to where the fabric is just sent through a machine coupled with a heat transfer paper that has the selected color, and that permanently dyes the color into the fabric, permanently impregnates it into the fabric, so even with washing, it never wears out over time. We can also do with fabric, you can do logos, you can do lettering, you can do any type of pattern, you can print pictures on the fabric duct, anything you want to do, you can do now with that process called dye sublimation. Logos and mascots, because schools do like to put their mascot on fabric ducts, those can also be done with a process called screen printing. So engineered distribution. Air distribution for textiles can be fully customized to meet the requirements for virtually any type of space. This is a picture of a gym. Before looking at the specifics of air distribution capabilities, it's helpful to define some terms: inlet velocity, static pressure, terminal velocity, and throw distance. So inlet velocity is the speed of the air as it enters the fabric system. This is measured in feet per minute and is a factor of the volume of air and the size of the diffuser inlet. Typically, fabric systems are sized for an inlet velocity of approximately anywhere between 1,100 to 1,200 feet per minute. Anything higher would require an internal support method. And because if not, it can cause vibration of the fabric, especially at the inlet. So diffuser for sound sensitive applications like theaters and recording studios should be sized for inlet velocities of anywhere between 800 to 900 feet per minute. And that will ensure that the space remains quiet during the operation of the fabric, of the HVAC system. Static pressure is the pressure of the air being contained within the duct. And static pressure is measured in the inches of water column. Static pressure is an important factor in how far the air moves away from the duct as it exits the diffuser. And typically systems are designed based on a static pressure of 0.5 inches water column. Unsupported fabric systems require a minimum of 0.25, so a quarter inch static pressure to maintain its shape. With half round systems, you can go even a little bit below a quarter inch, because you're not looking for that half round to remain round. Of course, it just suspends just below the ceiling at a half round moon shape, so you don't need to kind of force that round, so it can go a little bit below a quarter inch. Terminal velocity and throw distance. Terminal velocity is the speed of the air at a specific distance away from the diffuser. So this is the distance, this distance is a factor of the size of the distribution port. So however big the hole is, along with the static pressure inside the diffuser, that's going to determine your terminal velocity. The occupied zone of any space is defined as 6 feet above the floor and 1 foot in from every wall. That's the occupied zone. So within the space, the ideal air velocity is 50 feet per minute. Air moving faster than that will be sensed as a draft. So with fabric systems, you can be assured that you can get draft-free, comfortable air distribution in your space. Just a moment, I have to take some water. The throw distance, okay, so we're at throw distance. The throw distance is a distance away from the diffuser where air reaches the target velocity. So there's many ways to distribute air into a space, and I'm going to go over the air dispersion methods that most manufacturers do offer. So the first would be microperforations, then perforations, and then there's nozzles. So with microperforations, these are tiny laser cut holes that can be placed anywhere on the fabric duct. That can be located on the top, they can be located on the sides, bottom, however you like to place these, but they are very tiny holes. You would not want to use these if you're going to put this in an application like a gym or a pool. This is a method you would want to put in like an office space or maybe even retail, to where the ceilings aren't that high. Your throw distance isn't that long. So we're looking at anywhere between 5 to 8 feet of throw distance is where you want to use microperforations. Some manufacturers do have patented processes. There is a process on the market called directional microperforations, and how that process is done is because the holes are smaller than the thickness of the fabric. It allows for an edge of fabric that can be beveled with the laser to create kind of sort of like a directional throw. So this pushes, this allows the air to go out and more away from the duct into the space, rather than it just dropping into the space and filling the space slowly. Perforations is the most common method. These are laser cut holes. They are heat sealed, and that's important because with the heat sealing process of the holes, it prevents the holes from fraying for the entire lifetime of the duct. You never have to worry about those holes coming apart, even with washing. Without that heat sealing, of course, you would think if you were to cut through your t-shirt, you know that cloth and that t-shirt will fray over time, and eventually you would have to throw it away. So you don't have to worry about that with this, because of the polyester. It's a non-organic, and it's also very similar to plastic, though it's not plastic. But polyester is almost there to plastic, but with that heat sealing, it's kind of like if you light plastic on fire, how it kind of just, you will see like the plastic just turn hard, roll up on the edges, and it will heat seal. Well, it's very similar to that process that goes on with perforations in fabrics. These can be placed anywhere on the duct, top, sides, bottom, throw distance up to 30 feet. So you can use this in gyms, you can use this in pools, any type of application that has a throw distance up to 30 feet. Then there's textile air control pockets. So what happens with the perforations, the standard perforations, when the air is traveling through the duct, and I usually do this presentation in person, so it's kind of hard for me to describe. But if you look at that bottom picture, you will see the air deflecting towards the end cap. If the inlet is on the left-hand side, you see the air is bending. That can happen when you have high velocity in the duct. Doesn't happen all the time, but the way that the softwares, most manufacturer software is set up to where they can detect if there's going to be any sort of deflection issue, and based on what the software gives them, it will tell the person that's inputting the information in the system that they need to place these fabric pockets. So what they do is you put these, look towards the right-hand side of that picture on the bottom. You place the fabric pockets to shoot streams of air back at the deflected streams of air, and that straightens out the air streams to flow perpendicularly into the space. So then you don't have to worry about any type of draft issues. You don't have to worry about any dead zones happening around the inlet. And again, this is something that the software detects. You don't have to ask for it. We just, the manufacturer just knows to place them. So the manufacturer will fix any type of problem before they happen. Nozzles, okay, so nozzles can be done in 2 different ways, okay? Nozzles can be made in plastic. Some manufacturers do these in plastic. is not always the best way to do it. Plastic is not always the best way to do it because plastic can never match the same color as the fabric. Also, there can be an issue with corroding if you put the plastic nozzles in a pool environment. Eventually, over some time, the chloramines in the air can cause those to corrode and pop off over time. So you have manufacturers that do use a textile nozzle option, which is ultrasonically welded to the fabric duct itself. It's made from the fabric, the same fabric as a diffuser, so it will always match the color, and it will always keep the same continuous UL rating because you're using the same fabric as the diffuser itself. Okay, you can use nozzles for throw anywhere from 30 feet up to 100 feet, and the size is based on how far you need to throw it. So these can come in as small as 3/4 of an inch diameter. They can go 3 inches and up, 6 inches. I've seen these done instead of putting an end cap at the end of a fabric diffuser. I've seen owners wanting to throw air from the end of the duct. And so instead of placing an end cap, they just put this huge nozzle, almost the size diameter of the duct, to throw air across the room. So these can, again, be made in any size. They can also be made to be fixed. They could be made to be adjustable. So if you have an application, let's just say you have an assembly line in a manufacturing facility to where you need to direct air in different locations at different times, they can be made to be adjustable. They can also be made with dampers. So let's just say the first 5 feet of a fabric duct, let's just say, okay, let's say you have 20 feet of duct. The first 5 feet, you don't need to have any air. You want to shut off air on the first 5 feet. So you can put dampers on the inside to completely block off air the first 5 feet of the duct, and then the rest of the duct, the last 25 feet, will have air coming out of those nozzles. And of course, it will be custom designed and, you know, based on static pressure and all of that. That's all required, and that's information that's given to us by the engineer. Fabrics systems can also come with equalizers and dampers. Now, equalizers can either be fixed or they can be removable, and they're just, with the removable ones, they're zipped in components, and they just zip in at the inlet. These help to balance out any type of turbulence and provide any type of pressure balancing. So let's just say you have an issue to where maybe there's a project to where the correct size elbows in metal prior to the fabric, because we can only do fabric in exposed locations. So any metal prior to the fabric, let's say beyond the wall, above the ceiling, any metal prior to that, if it's not made in the correct size as far as radius elbows, if we don't have enough, let's just say clearance as far as metal ductwork prior to the fabric, there can be a little bit of air turbulence by the time it reaches the inlet of the fabric. So the way to straighten that out would be to use an equalizer, or you can choose to use a damper. Now the damper is adjustable. As you can see, the top picture is an equalizer. That's not adjustable. The bottom one is a damper that is adjustable. The opening at the end can be adjusted with it has a built-in fabric band that can be adjusted any way that it needs to be adjusted. So these can be placed at the inlet, or they can be placed anywhere throughout the fabric duct to where it's needed. Installation methods. So there's so many ways that, very simple ways that fabrics can be hung in a space. So the most simple and economical way to hang fabric is with a cable method. Cable can be, fabrics can be hung with cable, single row, double row, triple row, depending on the size diameter of the fabric duct. I've seen orders for fabric duct as large as 84-inch diameter. So if you can imagine, that duct is big enough for a person to walk through. So that would require a suspension method that can hold that full amount of fabric. With that, you will probably go with a 3-point cable suspension. But then there's also track suspension. Track suspension can be either surface mounted, or it can be hung below the ceiling with cable drops. Supports and tensioning. So what happens with a fabric duct when you don't have any internal supports, just like what you see here in this picture, it will hang 1.6 times its diameter. So if you have a really large diameter duct, it will look really ugly in the space, and it can cause a problem to where if there is no soft start or VFD on the unit at startup, it will cause for rapid inflation. That will cause for ripping and tearing at the seams. It will be detrimental to this fabric. We would not be able to warranty that. Okay, so if there is no soft start or VFD on the unit, you will want to choose an internal support method, especially if you're hanging in between any type of structural members like trusses or beams or anything like that, because you don't want the fabric to droop down onto any of those structural members, because over time it can eventually tear the fabric duct. So one of the most economical ways to correct that is to use arcs. The half arc supports are just placed at the top half of the inside of the fabric duct. It holds the duct round, but not completely. As you can see in that diagram, it looks kind of like an upside down egg. And that can cause a problem. If there's no soft start or VFD on the unit, there will still be a popping sound at startup. It won't be as loud as it would be if you don't have any supports, but it will still be a loud popping sound that can be pretty startling. So the better way to correct it would be to use full ring supports. This picture that you see here is actually for a gym. They have the duct running through the trusses, so they actually had to use the ring supports. If they didn't, that fabric would have draped over those trusses when the unit is off, and it would have tore the fabric. It would have wore out the fabric over time. Prematurely actually, and we wouldn't have been able to warranty that. So in this picture you would see this is actually ring supports, the air is off, and it looks like the air is on. And that's what you want that's actually what you want the fabric duct to look like at all times. So we manufacturers do strongly support using internal ring supports. There's also methods that fully tension the fabric, and different manufacturers have different selections that you can choose from. So you have this one option on the market that comes in these rings. This is the picture on the bottom left-hand corner. It comes in rings and rods that is not factory installed. So when it shows up to the job site, the contractor gets a headache because they have to put all of that stuff together. And then they have to slide the fabric over that. They have to create that skeleton and then slide the fabric over that. But then there's tensioning options on the market that are factory installed. On the top, you would see this is a internal tensioning support that is factory installed. It comes in zipper sections. So all the contractor has to do is just take it out the box, zip it together, hang it to the suspension. It's just simple as that. All of the supports are removable for maintenance. So whenever you need to take the fabric down to wash it, you would just remove the internal supports and reinsert them when you hang the fabric back up. So the basic parameters of designing a system. This is kind of redundant because we've already went through this. So again, you want to typically, the inlet velocity is between 1,100 to 1,200 feet per minute. We do not like to design over 1,600 feet per minute. Again, anything over that, you would definitely need some internal support, and more often than not, you would need that fabric tensioning support option that will prevent any type of turbulence from happening from very high velocity from destroying the fabric. And then also the sounds for sound sensitive applications, again, 800 and 900 feet per minute. At the inlet, ½ inch is typically what we design for static pressure, and you need at least a ¼ inch for the duct to remain round, especially if you don't have any type of supports. Codes and standards, again, this is going back to all commercial fabrics that are used for HVAC systems are UL listed. So they are approved in building codes all across North America. If the fabric is not UL listed, the manufacturer will let you know. If someone is making a selection for a fabric that is not UL listed, they will be made aware of that fact. But 10 times out of 10, manufacturers will always suggest you go with the UL, ULC listed, because every manufacturer does have options to where it's not UL listed. Why? Well, because not everybody has that standard. North America has that standard, but not some other countries don't have that standard. So we do have, most manufacturers do have fabrics that are not UL listed that are used for areas to where that is not required. But for North America, you don't have to worry about that. Manufacturers will always submit to you and will always select to you for UL, ULC listed fabrics. So when it comes to software, these can be done in many different ways. Every manufacturer has a different software. Some of them are proprietary software, and it's they put out shop drawings, simple data sheets. Some softwares will put out graphical flow profiles, CAD drawings, shop drawings, information detailing everything that's been selected or submitted on a fabric. It will show in pictures very similar to this. If you see right there in the middle, you can kind of see like an arrow pointing into the fabric duct that's drawn there. It shows you the CFM, it shows you the inlet velocity, it shows you the static pressure. Some of these sheets will tell you exactly what is on the project. Like it will tell you the fabric that's on the project, the installation method. It will tell you if you have ring supports or not. All of that will show on your data sheets. So you can be assured, engineers can be assured that they're getting properly working systems from the beginning all the way through to the end. There are some software components out there that can show sound level data. So if you have some sound sensitive projects like a recording studio, library, or anything like that, you can request for sound level data. And if it's really sound sensitive to where you have sound engineers on your project, manufacturers can also work with your sound engineers to make sure that they can get the sound level down to where it needs to be. So this is the fun part, applications. So indoor pools are the most common. Pools and gyms and fitness centers, of course, because it just simply, it makes sense. It doesn't sweat, it doesn't rust, it doesn't corrode. This is actually a picture of an residential pool house that was done for an architect. It was for his residential pool house. He actually ordered the fabric and he designed it, of course, drew it up, hung the fabric himself. So that's how simple and easy it is. Just anyone can do it. But he wanted his fabric duct to blend in with the actual structure. So it's very hard to tell unless you look really closely actually where the fabric duct is in this picture. But as you can see, it's going down, it's curving around the entire structure there. And if I look really closely, I see that there's nozzles on this, and nozzles were chosen, of course, because of the glass. That he needed to wash all of that glass with air to prevent it from condensating. I'm sorry, from condensation from building. Condensating is not a word. Then there's gyms and fitness centers. Again, it makes sense. Schools really like it to put it in their gyms. Bottom left-hand corner is actually of a school gym just outside of Texas. They wanted the fabric duct to blend in with their school colors, so the fabric was made in purple to match their purple school colors. But they like to put their mascot, they like to put their lettering, the school name or the logo on the fabric. Again, these can be placed anywhere for optimum distribution in the space. This large picture, as you can see here, is a half round duct that's mounted to finished ceiling inside of, looks like a cycling or a fitness center. Retail, these can be put in any type of retail space. Walmarts have been putting fabric in their distribution centers lately. Nike puts fabric in all of their outlet stores that goes up here in North America. Yeah, so pretty much anything, grocery, any type of retail space, you can use fabric duct in. Offices, okay, so offices, they can either have a finished ceiling, they can have an open exposed ceiling. This top right hand corner is actually a picture of a fabric duct that was placed inside of a Georgia Tech's maintenance facility, building and maintenance facility. And they actually have internal supports in that. They're hanging that around those, looks like floating ceiling panels. I'm not sure exactly what those are. I'm not an architect, but yeah, so there's so much that you can do with fabric duct in terms of the design, interior design, for it to fit in, blend in, or even stand out. Arenas and recreation centers are really great opportunities for fabric duct. Right there on the left-hand side is for a hockey arena. The one in the middle is I believe that was a selection for somewhere in Europe, but that's also a hockey arena. Right-hand side is for a trampoline park, indoor trampoline park. So we see a lot of trampoline parks going up here in Georgia. I don't know how it is in Canada, but they're going up all over the place. Kids really love to have fun in there. But the neat thing about that is it looks like that fabric duct isn't hung really high. So if some kid just goes crazy and jumps really high and hits the duct, he doesn't have to worry about it hurting him because it's soft. It's, you know, something bumps into it, it's just, you're just gonna bounce right off of it. Same thing for gyms. You know, in a gym, some kid just acting crazy and throwing balls at the HVAC ductwork. If it's metal, it can dent. A ball can dent it, but not with fabric duct. You don't have to worry about that. Restaurants and nightclubs, they like to get really creative in their space. So top right-hand corner is actually Lulu, Jimmy Buffett's sister's restaurant in Myrtle Beach, South Carolina. So she wanted the fabric duct to blend in with her interior colors, turquoise and hot pink. Really neat. On the top left-hand corner, that was somewhere in Asia. You can see the fabric duct was made with a print that's running to the head of that. I don't know, it looks like that could be a diffuser to where the air is coming out of that dragon's mouth, but the fabric runs right up to that head, so it looks like an actual dragon. We can also do data centers and server rooms. So again, with data centers, if they want to remove hot air from hot aisles, that can be done with rectangular fabric duct for negative pressure to remove hot air from hot aisles. We can make those in nozzles. We can make and point those nozzles directly at the servers, directly at the equipment to cool it down. They can also be made with the dampers to shut off air from different aisles at different times where needed. Recording studios, again, we've already went over that. Manufacturing and warehouses, so any type of industrial facility are really great opportunities for fabric ducts. Again, it's very lightweight. You're not adding a lot of load to the roof structure. We can do any type of fitting in fabric. We can do Ys, we can do Ts, we can do any size, radius, elbows, whatever you need to fit your design. Anything that can be done in metal can actually be done in fabric. Indoor agriculture. So this is very common for us in Canada, of course, especially with the cannabis grow. So agriculture really likes they're really onto fabric because, again, it doesn't put a lot of load on their structure, especially if you're using a greenhouse. Those greenhouses can't put a lot of load on the structure. So with fabric, it's actually a better option in agriculture to use over metal. And this can be done for any type of growing stage, from seedling all the way up to full growth. That's it, guys, with the presentation. So what we're going to do now is we're going to take some questions and we're going to answer questions specific to the generalization of this presentation. Any questions that's specific to Prihoda, I'll have to take my AIA hat off to answer those. So we're going to answer questions that's specific to this presentation. Anything specific to Prihoda, any questions specific to Prihoda, well, I have to take my AIA hat off and then end that.
All right, and this, we did actually get a couple questions that came in during the presentation, and we've answered a couple of them, but we'll put them out there to the group. The
Okay.
First question was, is there a ULC listing for fabric duct?
Yes, there is. We are ULC listed for Most manufacturers do have ULC listing also. Specific to us, yes, we do. We do have ULC listing. I can't answer for every other manufacturer out there.
And the specific certification is CAN ULC S102.2 if anybody's interested, but you'll see that answer in your question answer dialog box. Next question, in a school gym application, how does the fabric duct installation hold up to unsupervised students? I target practice.
Yeah, I touched on that just a little bit. So again, you don't have to worry about, it doesn't have the same issue with like metal. So with metal, if somebody throws a ball or some type of hard object at it, of course it can dent, or I don't know, possibly depending on what you're using, it could possibly put a hole in it depending on what they're throwing up there. But with fabric, you don't necessarily have to worry about that, because it's I don't know what word I should use for that, but if you could just, it's not a hard material. So if you're throwing anything hard at it, it's going to dent it, but it's going to bounce right back off. So it's not really a concern. That's why schools really like to use it. Schools actually used to like to use it in cafeterias, but they had the problem with the food fights, to where kids throwing food and then the food ending up on the fabric duct in the cafeteria, so they were having to wash it more often than they would have liked to. But I would think that that would even happen with metal too, with food getting on the metal. Somebody had to get up there and clean it. So yeah.
Okay, the next question is, what is the static pressure drop for a fabric duct? How do you size your air handling unit from a static pressure standpoint?
Sure. So the way that the way that fabric ducts works is on static regain. So whatever we design at the inlet, that is what you can expect through the fabric. Now, if you do have some offsets, you have some fittings, like let's just say you have a trunk line and then you have two branches coming off of that, there will be some static pressure loss, right, where it's transitioning from the trunk line over to the branch run, but it will balance itself out in the end. And the way that you would check that, of course, is the same way you would just get up there with your pressure balancer, you unzip wherever you like it, and you can test it. You can just stick it in the Airstream and test what's going on.
So like with the designs we've done, we've generally had about a 0.5-inch external static pressure at the inlet to the fabric.
Yeah.
Does that change, Anissa? Does that change from like especially long fabric ducts versus short ones?
No, because again, it works off of static regain. So by the time the air hits the end cap, it's going to regain. The pressure is going to regain in the duct. Where you're going to have your pressure loss points is if you're, like I said, you have any fittings or offsets, you will have some pressure loss right there at those transitions, but it will regain and balance out.
And those are all, I mean, from the software that we use, those the pressure at the inlet's also calculated for us. So we can make sure during a design stage that your air handling unit is covering that requirement.
Right. So again, I just want to reiterate, Nathan, that we do design even though we design standard at a 1/2-inch static pressure, and let's just say you have an engineer that would like to design it at 1 inch. They're saying there's 1 inch at the inlet. We can do that. You just have to let us know, because if you don't let us know what's at the inlet, we're going to design at a standard of a 1/2 inch. So then that's when the issue is going to come in if you're actually putting 1 inch at the inlet. So in that case, if that ever happens, of course, you can turn your unit down to where there is a 1/2 inch at the inlet, and then the fabric duct can work the way that it was actually designed.
Very good. Okay, so next question. Fabric duct was not approved in the city of Toronto and town on several projects. Any similar experiences happened to Textile or Odell? I can speak to Odell. We've had a number of installations within Toronto and had none that were rejected. The first one we kind of was a number of years ago was with the city of Mississauga. And once we showed that we had ULC listing, there was no issues with it. So I haven't experienced it. I don't know if Anissa, you've experienced it.
What was that last thing you said, Nathan? The last sentence?
The question was about approval in the city of Toronto or in town on several projects and whether or not that's been an issue.
Okay. Far as I know, I think you would know more than me, and I think you already answered that. But there shouldn't be any reason why we wouldn't be approved because we are ULC listed, and the only way that somebody wouldn't approve us is if they didn't know, like they just didn't know about fabric. No one ever told them it's something new, and they're not familiar with it. So if that's the case with you guys to where you weren't approved, it wasn't an issue of ULC. It probably was just an issue of lack of knowledge.
Yeah. We've installed in the city of Toronto. We've had no issues. We've got lots. We specifically have a number of fabric duct installations at Good Life. We actually did it with the city of Mississauga, so we haven't had any issues up to now. So. I don't anticipate any, given that they have the famous stroke spread rating that's required. I think this is a follow-up question to one of the previous questions about the school gym application. And I guess they're saying that the question was he was under the impression there was support within the ducts so they don't collapse without airflow. So I suppose the question would be, going back to the school gym application where students may be using the fabric as target practice, how robust are the supports? So.
Oh, the supports will hold up. The track is aluminum. The track can, well, for gyms, you wouldn't put stainless steel in there, but the track is always aluminum. And depending on what you're using, if that's surface mounted, it could be, because those can be fixed to structure too. So if you have structural beams, the track can be surface mounted to the structural beams. It would be really hard for anyone to kind of destroy that from below. If they're hanging below the structure with cable drops, you don't have to ever worry about that snapping or coming apart. It's really hard to destroy that from below. The only time that we have ever seen, which is very rare, I haven't seen it, but the only way that I would think that the suspension would lose its integrity is if it's designed improperly to where, which never happens because the software will tell us, but let's just say, let's go back to the case. If I designed it at a 1/2 inch static pressure, and let's just say you have 2.5 inches going through that fabric, there's going to be some turbulence issues. There's going to be some problems that will cause for the fabric duct to violently shake. And yeah, it can kind of loosen the suspension over time. But again, these are issues that you don't necessarily have to worry about because with us, with Prihoda, we do make sure that you're getting a perfect design, a properly designed system from the beginning all the way through to the end. So, but yeah, as far as anybody destroying it from below, yeah, that will be almost impossible for them to do that.
Okay. So the next question is, how do you do elbows in a fabric duct?
Pretty much the same thing as metal. We make the proper radius elbows, 4-gore, 90-degree radius elbows. And even if you're using internal support methods, we put the internal support method even inside of the elbow. So it keeps the same continuous look. So you won't just have the diffuser that's internally supported and then the elbows are draping. So yeah, even with the internal supports, it goes all the way through every single fitting. Even if you have T's or Y's, the internal support method even goes in those.
Yeah, I can speak from experience. We've done some pretty crazy layouts with not just 45s and 90s, but angles of odd 13 degrees and 27 degrees, odd angles. They accommodate all of them. So that is something that's very flexible and very easy to work with fabric.
Yes.
Okay, I have, that's the last question. So it looks like, I think, unless there's another question coming up. Nope, that's the last question.
Okay.
So appreciate everybody's attention throughout the presentation. And Anissa, again, thank you very much for taking the time to present to the group here today.
Yeah.
Appreciate your time today. And again, thanks again, everybody. Stay tuned for our next isolation intelligence webinar, which will be on Wednesday, and details of that will be going out this afternoon, later on today. It will be specifically on filtration and viruses being put on by TriDim. So appreciate everybody again attentiveness, and we'll hopefully see you again soon.
Thank you, guys. Thank you, Nathan. And again, remind Nathan if you need your AIA certificate of completion, just reach out to Nathan and I'll make sure to get that over to you guys. Thank you.
Thank you.